Prayag, the city of mythological, historical as well as political significance. Located at the holy Triveni Sangam, this city has always been of special importance right from the period of the Gupta emperors. It has been the Janmabhoomi of Pandit Jawaharlal Nehru, a sacred destination for millions of devotees who take a holy dip at Triveni Sangam, especially on the occasion of Kumbh Mela. With the passage of time, Allahabad has seen substantial increase in vehicular traffic. The old bridge over River Yamuna is a dual road-cum-rail bridge. Built in the mid-20s of the last century, this bridge is proving to be inadequate to the current traffic demands. Today, frequent traffic jams have become a regular feature of the city. To overcome this, the National Highways Authority of India, NHAI, decided to construct a new cable-stayed bridge parallel to the existing bridge under financial assistance from the Japan Bank for International Cooperation. The execution was entrusted to the Hyundai-HCC joint venture. The supervision is being done by Covispan JV. Following a detailed survey of the area on both banks of the Yamuna, the National Highway Authority of India finalized alignment of the new bridge connecting GT Road on NH2 on the Allahabad side with Rewa Road on NH27 on the Naini side. The total length of the connection is 5.155 kilometers, comprising of 3.5 kilometers of approaches and 1.5 kilometers of actual bridge. The river Yamuna is still extensively used for navigational purposes by local people. Hence, another challenge before NHAI was not to disturb the navigational use of the river. NHAI, therefore, decided to opt for a cable-stayed bridge, as it provides wider navigational passage. For speedy and systematic completion of the work, the entire scope of the work was divided into 4 independent modules. Module 1 contains cable-stayed portion of 630 meters length with central span of 260 meters, supported on double D well foundations with depth up to 40 meters. The approach viaduct of 515 meters length on the Naini side with spans of 60 meters founded on circular well foundations is included in Module 2, whereas the 365-meter long approach on the Allahabad side with 25-meter spans supported on 1.2-meter diameter piles is included in Module 3. Approach road works, which includes embankment works, retaining walls, cross-drainage works, pavement works, safety signboards, etc. are included in Module 4. After the center line of the bridge was established with the help of precise survey, foundation works were taken up. Foundations of the pylons P17 and P18 supporting cable-stayed portion had to be built in the middle of the riverbed, which were enclosed by coffer dams, access to which was provided by jetties constructed on both banks. The jetty on the Naini side is 260 meters long with double sheet pile enclosure, driven by vibro sinkers. The jetty on the Allahabad side is a timber structure 100 meter long. Well foundations. The well foundation work is executed in the following stages: cutting edge, well curb, staining, bottom plug and well cap. Cutting edge. The cutting edge serves to cut through the soil strata and facilitates the sinking of the well to the desired founding level. The cutting edge consists of back-to-back angles welded with a 12 mm plate bent to shape on the outer periphery. Before the final assembly of the angles, holes are drilled into the face of the angle to receive the bond bars. The cutting edge is placed on timber sleepers after the ground is leveled and center point is established. Well curb. On the cutting edge, well curb is cast in concrete within tightly fitting inner and outer forms with embedded reinforcement. Plywood formwork of PERI make is used for pylon wells. The concreting is carried out in layers using concrete pumps and transit mixers. Needle vibrators are used for compacting the concrete. The well curb is pitched into the ground by removal of sleepers placed beneath the cutting edge. The dredging inside the well curb is carried out manually. Well staining. When the well curb is partially sunk into the ground, well staining is built in lifts of 2.5 meters and sunk into the ground. Well staining for pylon wells is built in lifts of 2 meters height. The concrete is transported from the batch plant and is poured using concrete pump. For P17 well, the concrete is placed by crane and bucket arrangement. Concreting is done in clockwise direction in layers. The green concrete is vibrated using needle vibrators. Well sinking. Well sinking is an important activity and is carried out with utmost care. The wells normally sink into the ground by their own weight. The soil underneath the cutting edge and in the central dredge hole is removed by using grabs. Continuous grabbing operation is carried out till the well is sunk down to the desired level. In the case of hard strata, chiseling and grabbing method is deployed to loosen the strata, and muck is grabbed out from inside the dredge hole. Care is taken to carry out grabbing in a uniform manner inside the dredge hole. In the case of double wells, the grabbing is carried out uniformly in the outer dredge holes, employing 2 cranes followed by the inner dredge hole. Readings are taken during sinking on the gauge marks to measure any shifts or tilts, which if noticed are corrected by eccentric dredging or by placing eccentric Kent ledge loads and carefully monitoring the movement of the wells. Well plug. When the well reaches the founding level, grabbing operations are discontinued and the well is made ready for plugging. Confirmatory bores are taken to study the soil parameters. Concreting of bottom plug is carried out by tremie arrangement. The tremie pipe with tightly sealed joints is lowered into the well and a hopper is placed on top to receive concrete. A swivel concrete distributor connected to the concrete pump is placed at the center of the well. The concreting is carried out in clockwise direction, moving from one hopper to the other. Pile foundation. Module 3 of the project, namely approach viaduct on the Allahabad side, is founded on 1200 mm diameter concrete piles. Each pile group consists of 4 piles with a total of 130 piles for the viaduct. The board cast in situ piles are installed using Casa Grande piling equipment using retrievable casing pipes. The oscillator of the piling machine is placed at the pile coordinates previously marked on the ground. Casing pipes are driven into the ground by rotating the oscillator. Verticality of the casing is checked at regular intervals. As the casing pipes are driven, a tiny grab is employed to remove the muck from inside the casing. When the casing pipes are driven to desired depth, soundings are taken to check whether further boring operation is required. Thereafter, the reinforcement cage is lowered into the bore. Concrete is placed inside the casing by crane and bucket arrangement through a tremie pipe of 200 mm diameter fitted with a hopper. Concrete is delivered continuously to the bottom of the pile bore in stages of 3 meters. When each stage is completed, the casing along with tremie is lifted out and concreting is continued up to about 1 meter above the cutoff level. The pile is then chipped off up to the cutoff level and integrity test is carried out to check the soundness of pile concrete. Load testing. The installed piles are tested for the working load capacity envisaged in the design. Tests include 2 initial and routine load tests each. The initial load test consists of vertical as well as lateral loading. The vertical load is applied by a kentledge in the form of jumbo sandbags, each weighing 1 ton, in 9 tiers corresponding to a total load of 850 tons placed on a platform erected on top of the pile. Increments of 20% of the test load are maintained for 1 hour and the displacement of the pile is recorded by means of dial gauges. When the final load increment is given, the final displacement is noted and working load is calculated from load displacement graph. Pile caps. Before commencing the activity of pile caps, all the piles are exposed and chipped off to the cutoff level. 100 mm PCC is laid on the plan area of the pile cap and cured. Concreting is carried out using concrete pump and vibrated using needle vibrators. The top surface of the pile cap is made plain using trowels and curing is carried out by ponding arrangements. Pier shafts. The pier shafts in Module 3 are of size 1200 mm by 2000 mm in plan with heights varying from 2.5 meters to 7.5 meters and are cast in single lift. The steel forms are made as per the design. When the rebar fixing is completed for the pier shaft, the form works are placed and aligned for the verticality and center line. Concreting for the pier shafts is carried out through crane and bucket arrangement, and it is vibrated through the needle vibrators. Deshuttering for the pier shaft is carried out 24 hours after concreting. The surface of the shaft is wrapped with Hessian cloth and curing is carried out.